So hello everyone, welcome back to another particular lecture of our Reagent Chemistry lecture series, and this is class 30. And in our previous discussion we talk about the unusual oxidations like uh, metal mediated oxidations, hypervalent iodine mediated oxidations, as well as the radical mediated oxidation reagent, which actually do oxidation of alcohols to aldehyde or keto. So in this particular class onwards, we start about oxidation of aldehydes to carboxylic acids. Okay, so first of all, this is aldehyde. This will undergo oxidation to get their corresponding carboxylic acid. And how it is oxidation? First, the oxygen is inserted here. That means it is oxidation. Also, here the carbon oxidation number is +1, and here in the carboxylic acid, the carbon oxidation number is +3. That means it will go +2 oxidation is happening here, aldehyde to carboxylic acid. Now let us understand that what is the methods that actually capable to do this type of oxidations. Okay, so Pinnick oxidation is the most important oxidation pathway to do aldehyde to carboxylic acid oxidation. Then it is the KMno4, is the vigorous oxidation observed. Then Tollence reagent. Tollence reagent is also useful for synthesizing aldehyde to their carboxylic acids. PDC in DMF, that is already discussed, and Jones oxidation in room temperature. These two are actually already discussed in our previous lectures. Okay, so now let us start about our discussion with Pinnick oxidation. So sodium chloride, NaClO2, it is actually called as the Pinnick oxidation reactions. So sodium chloride is a mild, inexpensive and selective reagent for the oxidation of aldehydes to their corresponding carboxylic acid under ambient reaction condition. And this question is come in the net also, net exams. So this is the structure. Okay, now in presence of sodium chloride, and there is a one acid H plus condenser is there. There is a sodium H2PO4 and 2-methyl-2-butene is used to synthesize this particular aldehyde to their corresponding carboxylic acid. Now in the reaction condition, you may find that what is the role of this 2-methyl-2-butene? Basically, this 2-methyl-2-butene is often incorporated as an additive and has been proposed to function as a scavenger of any electrophilic chlorine species. Here in this particular pathway, this is a HOCl generated in this particular reaction, and this particular question is come in the net December 2023. So let us understand the mechanistic pathway first. So mechanism is that initially these two are actually combined to generate HClO2, this particular compound, and then this particular lone pair of aldehyde carbon will actually captures this particular proton here, and it will generate this, and this particular acts as a nucleophile. So here the electrophilicity of this particular carbon center getting increased, so that this particular negative is attacks here, and this particular bond goes apart to remove the positive charge from the oxygen here. After that, this particular oxygen lone pair will capture this hydrogen, this particular black hydrogen. Okay, so the color coded is here, so you can easily understand or follow. So this will there, and this actually bond will goes here, and the overall this OCl bond breaks apart. So we got HOCl and our corresponding acid, and now this particular HOCl react with this 2-methyl-2-butene to scavenge to get this particular compound, and it will be out from the reaction mixture. So this is the typical mechanism of the Pinnick oxidation reactions. So let us talk about some examples. Example as already discussed, that here you can find this, the CHO is there, like aldehyde group is here, so it will convert it to their corresponding acids. Also in this particular reaction, here is the aldehyde. Okay, you don't have to bother about other functional groups here, just find the aldehydes here. So here it is aldehyde. In presence of Pinnick oxidation reaction condition, it will generate their corresponding acids. Okay. Now let's talk about other reagent, that is the KMno4, that is the potassium permanganate. Now potassium permanganate is a strong oxidizing agent and its reactivity depends on whether it is in use in acid condition, neutral condition and basic condition. So it has been found that in acid conditions it is actually show vigorous oxidation, so it will transform aldehyde to their corresponding acids, and the Mn7 here, it's actually reduced to Mn2 in this particular reaction conditions. And in basic and neutral condition, MnO2 is usually formed, and we know that MnO2 has been used for oxidation of allylic, benzylic and propoxylic alcohol that I already discussed in the previous classes. Okay. So it is written here that this combination, this is a KMno4H2SO4 in a water medium, is oxidized aldehyde and the corresponding carbonyl acid over a large pH range. Alcohol, alkenes and other functional groups are also oxidized by potassium permanganate. That's why this particular method is not a chemoselective reactions. Okay, so this you have to remember. But in the case of Pinnick oxidation condition, this is chemoselective. But here KMno4 is not that much chemoselective. Okay. Now let's talk about Tollence reagent. This is silver oxide. Tollence reagent is used to synthesize aldehyde to their carboxylic acid derivatives and is a very mild reaction conditions. So it's only able to synthesize aldehyde to carboxylic acid. So here you can find the different groups, functional group is there, but it will actually do its job to synthesize aldehyde to their corresponding carboxylic acid. Similarly, here also here is a carboxylic acid, the aldehyde is present here. In presence of Tollence reagent condition, it will form carboxylic acids. Now, let us talk about the pyridium dichromate. As I already discussed in our chromium based oxidation, that PDC in presence of DMF solvent, it will show direct alcohol to carboxylic acid because of the water content. They actually increase the reaction rate as well as the reactivity. So the non-conjugated aldehyde are readily oxidized in the corresponding carboxylic acid in good yield in DMF as a solvent. So this is our corresponding aldehydes. It actually PDC in DMF condition, it will move towards the acid part. Okay. And also as I discussed that primary alcohol are oxidized to their corresponding carboxylic acid in good yields. So here this is the primary alcohol. It react with this particular PDC and DMF condition. As we know that DMF contains water which actually accelerate the reactivity of PDC. So directly primary alcohol to acid conversion observed. Okay. So with this we have to end this particular segment of aldehyde to carboxylic acid synthesis by using certain reagents. So in the next class, in the class 31, we will discuss oxidation of aldehyde or ketone to their corresponding esters. So thank you for listening this particular class.